Okay, I think this is the last geometry question, and it's all about the midpoint theorem. Heck, let's try this. In the sketch, we have triangle DEF, a big triangle here, and there's J on DF and G on H and on DE such that HJ is parallel to GF, and EF on GF intersect at K, and DJ, they're giving us this thing, DJ with the triple lines equals JF, and EK equals KJ. So that's given. The things with red aren't given. They're not given, so we've got to figure them out. Now, there's this thing here. Where we're supposed to prove, let's go back a little ways. Sorry, we weren't given it. There's all the stuff that we're given in that picture. This is the story, and here's the diagram that's given. And you're asked to prove that DH is equal to GE. I'd done that the other, so sorry. This is where we start off. Prove giving reasons that DH, you're given all this stuff. There's all these different triangles going on. There's a triangle here, there's a triangle here, there's a big triangle. I see 3 triangles, and I see these parallel lines cutting across. Okay, now let's start. We're going to prove that DH equals GE. Well, the first thing, in triangle DGF, let's go, DGF. So just look at that triangle right there. We've got 2 things going on here. From a midpoint, we've got a parallel line going over to another point. Now there's a thing that says the conforce of the midpoint theorem says that if a line is drawn through the midpoint of one side of the triangle and it's parallel, it'll bisect, it cuts these other into 2 equal pieces. So that means that GH equals HD because of the midpoint theorem, but we have to say converse of the midpoint theorem because JH is this parallel line going across here that's on a midpoint. If it goes to this side, it'll break these into 2 pieces. H will be a midpoint. Well, for the same reason, GE must equal GH because there's a triangle, let's see here, triangle JHE. See that triangle there? There's a parallel line cutting across it. And it is also, from a midpoint, it's parallel, so it makes G the midpoint here. So it breaks GE equaling GH. Also, converse of the midpoint theorem, and it's because JH is parallel to JK. Well, I just proved that GH is equal to HD and GE is equal to GH. That means that this HD or DH must equal GE because they're both equal to the same thing. And there it is. We proved it. Let's just try this last one here. It's a little bit tricky. It's tricky, but it's sort of interesting. In this question, they say that JK is 8 centimeters. And they're asking us to find this KF thing out here. Well, do you know if you know that this is 8? The midpoint theorem says that if you have a parallel line going through the midpoint, that parallel line in the middle is always half as big as the one at the bottom. This one's always twice as big as this one if it goes to a midpoint. So that your first part of getting this question right is that JH is equal to 16 centimeters. And that's the midpoint theorem because of the parallel lines going across, JK paying parallel to HG. Okay, so we've got that 16. But now, let's look at this other triangle. Let's look at the triangle DGF. See that big triangle there? If that's 16 there, that goes to a midpoint. This one's got to be twice as much. It's got to be 32 for the same reason. The midpoint theorem says the line at the bottom is always twice as big as the line going across if it goes to a midpoint. That's a midpoint theorem. So we know GF is 32 because of the midpoint theorem, because GF is parallel to HG and it goes to the midpoint. Okay. Well, if we know that this whole thing's 32, then we just have to go 32 minus 8, and we get what KF. Therefore, KF must be 24 centimeters. And there you go. That's it.